So welcome to lesson 23 or learning goal 23, where we're going to try to come up with an understanding of a number to the power of 0, or a to the power of 0. The a right there represents any number, so don't worry too much about what is a. A is a variable; it represents any number, and we'll go into what kind of how that affects what we are doing in just a little bit. So let's do a little bit of review first. First thing that we need to want to take a look at is that a power is an operation which represents repeated multiplication of a base. And that base can be really any number. It can be positive, it can be negative. Okay. The number of times it is multiplied is dependent on the exponent. So if you remember from our previous lesson there where we talked about bases and exponents and powers, when we talk about a power, it is repeated multiplication, the number of times that we have in the exponent. So something along this line right here, we have 4 to the power of 3, or 4 cubed. This is exactly the same as 4 times 4 times 4. Right, 4 times 4 times 4. So this would be what 4 to the power of 3 represents, and we can multiply it together 4 times. So it'd be 4 times 4, which is 16, and then 16 times 4, which would give us a total of 64. So this would have an answer of 64. 4 to the power of 3 is 64. 4 times 4 times 4. This is what we're talking about when we talk about as a power. Now, this works very well, okay, while natural numbers are used as the exponent. Okay, so while natural numbers are used as the exponent, it's fairly straightforward. We just multiply by the number of times that we have in that exponent. Now, we can also have, exponents can also be non-natural numbers, such as 0, or they could be negatives. Now, we're not going to deal too much with the negatives today, but we will take a look at the 0. But as an example of this here, so examples that we could have, so things like we could have 4 to the power of negative 4. Okay, 4 to the power of negative 4. This is very different than 4 to the power of 4. Okay, again, we won't get into this a whole lot. We could also have something like 5 to the power of 1/5. Okay, so we could do something like that. We could actually have a fraction in there. We could do decimals as well. Or, and the big one that we're going to be taking a look at today is what happens when we have to the power of 0. Okay, so we have to the power of 0. And we will be taking a look at what does that represent today. Now, as I mentioned in this lesson here, negative exponents won't be used at this time, but the exponent 0 will be. Okay, so we're going to be taking a look at the exponent 0. Now, I'm going to go through 2 different methods on how to prove the value of an exponent 0, and in fact, it's always the same thing, and we'll get into that in just a little bit. But we're going to go through a couple different examples on how to prove that. So let's take a look at the first example. This is an inductive reasoning example where we're going to be taking a look at a pattern which forms to solve a problem. So the first one, numbers that we're going to take a look at are base 10. So let's look at base 10. We did this back in a few lessons ago, and we know that an answer in base 10 is a 1 with the number of zeros that the exponent says. So 10 to the power 4 is a 1 with 4 zeros. I'm going to put a comma in there. Okay, so 4 to the power of 10 is 10,000. 10 to the power of 4 is 10,000. 10 to the power of 3 is 1,000. Again, it's a 1 with 3 zeros. 10 to the power of 2 is 100. 10 to the power of 1 is 10. And based on that, 10 to the power of 0 is just a 1. Okay? So here we have a 10 to the power of 0. Our answer is 1. And this is kind of the pattern that we followed. We saw this when we dealt with exponents. Even when we got negative exponents, we saw that as well. Okay, here 10 to the power of 0 is 1. Now, Is there a pattern that's forming here? Well, yeah, it's the number of zeros that we have. That's kind of our pattern that it's forming. But it doesn't really tell us a whole lot what's going to happen with a 4, because 4 is very different. 4 to the power of 3, as I mentioned, is 4 times 4 times 4, and this equals 64. Okay, so 4 times 4 times 4, which is 64. 4 to the power of 2, 4 times 4 is equal to 16. 4 to the power of 1 is just 1 4. And so what is 4 to the power of 0? Okay, well, there's got to be some sort of pattern forming here. In each case, we have 1 less 4. So if we go from 64 and divide by 4, we get 16. 16 divided by 4 is 4. 4 divided by 4 is 1. Interesting. So based on this pattern here, okay, this one would be 1. If we do 64 divided by 4 is 16. 16 divided by 4 is 4. 4 divided by 4 is 1. Not 0, it's 1. Interesting. And here it was also 1. Now, does that keep working with that same pattern? Okay. Both of these patterns that we have show that the exponent 0 gives an answer of 1. Okay? But does this work in all scenarios? Now, when we do an inductive proof, inductive proof means that we are taking a pattern and trying to build off that pattern and trying to see more on that pattern. Let's see if it works with a negative base. Does that same pattern work with a negative base? 6 to the power of 3. Well, instead of going through negative 6 to the power of 3, okay, this is going to give us an answer of negative 216. Okay. I did this ahead of time, so you don't have to worry about. I didn't show my work, but that's okay in this case. Okay, I'm just using it as an example. All right, so negative 6 to the power 3 is negative 216. Negative 6 squared is 36. Negative 6 to the power of 1 is negative 6. And now let's take a look. If we divide negative 216 by negative 6, we get 36. And I'm just going to go through the negative 216. Negative 216 divided by negative 6 equals negative 36. And so now, or sorry, positive 36. Now we're going to divide, I'm going to divide this by negative 6. I get negative 6, which was the next value that I had there. And I'm going to divide this by negative 6, and I get 1. In fact, it gives us the same value there. It is 1. Okay. Based on this scenario, based on this reasoning that we have here, we can assume, based on the pattern that is forming, now this is a pattern, okay, here's the pattern, here we divided by 10 every time, here we divided by 4 every time, here we divided by negative 6 every time. Based on that pattern, we're going to see that anytime we have a power to the 0 exponent or the power 0, our answer is 1. Okay. Now, based on this pattern that is shown in all scenarios, it looks like whenever the exponent is 0, the answer is always 1. Okay. Is that always the truth? Let's take a look at this one. This is a negative 5 to the power of 0. 5 to the power of 0, right there, the answer is 1. But remember, our answer to this is going to be a negative, okay, because we have a negative there. So in this case here, it's going to be negative 1. Okay, so we can show, and again, this is using inductive reasoning, that anytime we have the power 0, our answer is 1, okay, using inductive reasoning. And that's the important thing to understand is inductive reasoning.